All right, there's a couple of good questions where we use either this formula, theta equals S over R, or this one, RW. This one here we use if there's motion, if there's some kind of velocity or speed. And this one we use if we're just looking at a circle and trying to find distance around something or an angle or something like that. So this one says it has a wheel, and it has a 26 centimeter radius and is marked at 2 points. So maybe here and maybe there. I don't know. And they say the distance between those marks is 17 centimeters. So this distance here, from here all the way there, is 17 centimeters. And that's what's known as an arc length, or S. And they say what angle to the nearest tenth of a radian is between those. So they want to know, if I draw a line here, they want to know what that angle measurement is there in radians. And that's what that formula is. So theta equals S over R. S is 17, radius 26. So then go to decimals. I'll pull that up quick. And I want to go 17 divided by 26. 17 divided 26. 0.6538. 0.6538. 0.6538. Oh, they say the nearest tenth, so equals 0.7 radians. We could convert that to degrees, so 0.7 rads. So you could multiply it by 360 degrees over 2 pi rads. And that'll give you a degree measurement, but they just asked for radians. Okay, here's another one. Cylinder on John, 38.5 centimeter diameter. Okay, gonna have to cut that in half to be a radius. Linear speed, that's V, on a point is 128 meters per second. What is the angular speed, that'll be the W, of the thing in revolutions per hour? Interesting, they want revolutions per hour. Usually they'd want radians, but okay. So here's our formula. And they want to know what the angular speed is. So I have to divide both sides by R. So I get the angular speed as the velocity divided by the radius. The velocity is 128 meters per minute. And the radius, I have to cut that in half. I think that's 19.25 centimeters. Okay, and now they want to know the angular speed in revolutions per hour. Okay, one issue I have is this is centimeters and that's meters. So I'm going to multiply by 100 centimeters is 1 meter. So the meters and centimeters both cancel. So now I have to figure that out. 128 times 100 over 19.25. Okay, calculator. Okay, I forget the numbers. 100 times, what was it? 128 divided by 19.25. 664. Whoops. So this is 664.935 radians per minute. So when you use this formula, the units that come out, and you can't see them there, but the units will be radians per whatever time they give you. Okay, so now the question says, what are the revolutions per hour? So I'm going to have to multiply. I have to change my radians to revolutions and my minutes to hours. So I'm going to multiply this by, let's change the radians first. I know that 2 pi radians are equal to 1 revolution. Okay, that'll get rid of the radians. And then I have to change the minutes to hours. So 60 minutes are the same as 1 hour. So the minutes cancel. So the units I'll have now revolutions per hour. Let's do that on our calculator, see what we get. So I have to take that 64 and times it by 1 divided by 2 pi. Where's my pi? Right there. 1 over 2 pi. And then times that by 60 over 1. So this will be 6,349.66 revolutions per hour. All right, hopefully that helps you with those two questions.